In this video, we'll finish the remaining content of this unit. So as objects, systems, and systems of systems become increasingly interconnected, the self-operation of these systems must be taken into account by design. Because if you don't have them in design, so when later on you need to modify it, it will be difficult. And also later on, if some attacks happened, if the consequence will be very terrible. So factoring safety into the design of an IoT system is an extraordinarily difficult endeavor for many applications and scenarios. The reason is that, as we mentioned, so IoT is built based on internet. So for internet, we already have many attacks, right? For IoT, we also involve a lot of physical devices, the machines, and also people actually. So the safety loopholes can come from anywhere. So for this session, we give some 3 application contexts to help you get some idea of the safety issue in IoT. Before I move forward, let's define safety. Okay, so we talk about safety a lot, but what can be a good definition of safety? So safety can be defined as the condition of the system operating without causing a suitable risk of physical injury or damage to the health of people, either directly or indirectly as a result of damage to the property of the environment. So the definition is quite long, but to be simple, we want the system to perform as expected, right? With safety, security, privacy, reliability, and resilience. So with that in mind, let's look at some IoT scenarios. The first one is in the automation and robotics. There are numerous example scenarios where humans and robots may need to require interact. Nowadays, in movies and also in some commercial retailers, you have seen that people are working closely with robots. Sometimes the robots have a very nice looking, just like humans, right? So from a security point of view, safety cannot be guaranteed if the robots in question may be influenced by malicious actors, basically by bad guys. So if they happen to be connected to the internet, they will have significant security requirements. Any change or compromise to the safety mechanism implemented could be harmful to people and operator and also the process. And for the safety in automotive systems, so especially nowadays, we are having the self-driving vehicles. The automotive industry have been well-established safety guidelines. So now with the introduction of autonomous vehicles, we have new safety concerns. This is related to both the autonomous driving capabilities, permissible, as well as the remote hijacking. For the autonomous driving capabilities, so actually there are 6 levels. So Tesla is actually targeting the final level. Basically, it is total autonomy. And in that case, because the vehicles are connected to the internet, so you have seen this maybe in the recent movie. What's the name? Fast and Furious. It's episode 8 or 7. So you see that a fleet of vehicles can be hijacked, and they are just punching into the actors, right, in that movie. So that may be the reality in maybe 10 years. So those are the safety concerns in automotive systems. And also for smart cities. So actually now we are moving towards this big dream. Yeah, it is a really big dream. For what we mentioned earlier, the robots, the automotive vehicles, actually they can all put into a smart city, right? So smart cities are increasingly complex and interconnected systems mostly comprise systems for infrastructure. So it includes transport, water, energy, and civil and communication infrastructure. So the idea of the smart cities is to improve services and provide enhanced efficiency, right? So for example, for one example is the lights in the highway. So there are sensors for those lights. If there are no vehicles around, so those lights will turn on at a low level. Basically, the light will be relatively weak. But if the sensors detect there are vehicles on the street, then the light will be working in the normal mode with suitable lights for the vehicles. This is an example. There are many other examples. For example, for the smart grids, basically it is for the electricity supply. So it can allocate the electricity based on the usage of the electricity across the city. So that's another example. So as you can see here, for the water, for the energy, and for the communication, those kind of things, they are vital for a city and for people. If the water supply is disrupted or the energy is cut, just think of the Texas in the past week, right? So that will result in severe consequence. In that case, the security for smart cities, I can say it is the most important. It is beyond the vehicles, beyond the automotive vehicles, beyond the automation and robots. Because for those cases, it may affect a small area, but for the city, well, it can result in catastrophic consequence. And now the last extensive, the last extended topic from security is the privacy. For these two terms, they are related in my opinion, but they are not the same thing. So for privacy, basically it means you don't want your message, your data to be known by someone you don't want to, right? Devices connected to the IoT generate, process, and share sensitive data. They are critical for security and thus must be kept private. In other hand, with that said, we know that if we can keep something private, most of the time it is secure, right? So one of the main reasons behind the amount of vulnerability are the characteristics of the devices forming the IoT. Because we have different devices, they have constrained resources in terms of power, computation, so that some security and mechanism cannot be used there. And also they are decentralized. That means that we don't use a central controller to control all the devices. Basically, the devices are what? They are autonomous. They are self-surviving. So this is good for the system, but on the other hand, we don't have a leader, we don't have a leader to guide, to oversee all items. That will bring some challenges to security and privacy. So the ubiquity of the IoT makes large amounts of information easily available to eavesdroppers, making privacy protection increasingly challenging. So we need to conduct research to protect the content of messages. Yeah. So basically, the messages can be captured by other people. That's beyond doubt. But we just make sure that they cannot know what's in the message. Another security problem stemming from the decentralization of IoT systems is the establishment of trust among actors. So because we don't have a central leader that oversee the whole system, so every system, every subsystem, or every network is just think of that every sub-network, every small system is a unique entity. So just think of the human world. So if there is a new neighbor in your community, then basically you need to establish the trust with each other, right? For people, we may look at their behaviors, look at their talking, something like that. But for the IoT systems, with the introduction of new networks, new devices, new systems, so how do we find a way to trust those systems? So this is also another research area for the privacy in IoT. And there are some other future development in security. So those are too technical, so I will leave it as a reading part of this chapter.